Hi everybody, Miss Lorenz here. I'm going to talk about the sections 3.6 and 3.7 for grade 6. We're talking about properties here. There's a lot of properties to talk about. And we're also going to talk about simplifying. So I'm going to go to the next page as well. But I still have decided that I want you to do these two sections together before your next superset. Some of this is a review for you. Some of it is not brand new, but maybe just a little new. So I think doing these two sections together makes a lot of sense. All right, so let's review our properties. Remember, and again, if you don't have your notebook out, please make sure that you have it out. You might look into some previous notes you have in your notebook and see if you already have this down. If not, make sure you get it down. So to start with, I want to talk about these three properties of math. Think of properties of math as like the rules of math or like the laws of math. These are the things that we assume to always be true, and we operate under those assumptions because they are true always. So the commutative property of math means that if A plus B is equal to B plus C, and A times B is equal to B times C, then we are showing equality by commuting or moving around our numbers. So commute, if you look at the word commutative, you can see the word commute in here. And think about like commuting or driving from one place to another, or traveling from one place to another. We sometimes use the word commute to describe that. Commutative property has that word inside. And so when we use the commutative property, we're really just moving around these numbers. And we know that when we do that, it's equal to what happens on the other side. However, really important, you guys, this only works for addition and multiplication. So let's use a couple numbers as an example. 2 plus 3 is equal to 3 plus 2, right? We know that. It does not work for subtraction. Look what would happen. 2 minus 3 is negative 1. Is that the same as 3 minus 2, which is positive 1? No. So the commutative property does not work for subtraction. Same with division. So let's use 2 and 3 again, and let's multiply. So we know that 2 times 3 is equal to 3 times 2, so it works for multiplication. 2 divided by 3 is 2/3. Is that equal to 3 divided by 2, which is 1.5? No. So it only works for addition and multiplication. Now let's go to the associative property. The associative property, look inside the word associative, you hear the word associate. And when you associate with someone, it's like you get to know them or you work with them. Or I always like to visualize that you're shaking their hand. You're like associating with them. And so here we are showing that A and B are associating together. So if we have an A and B associating, and then we have a C, we know, according to the associative property, that that's going to be equal to if A is added to the B and C that are associating. So B and C can associate, and it's going to be the same as if A and B associated. That's the same with multiplication as well. A times B in the quantity times C is equal to A times the quantity B times C. This same thing only works for addition and multiplication. So just like before, if we tried to apply this to subtraction and division, it would not work. Really important that you understand that. Lastly, the distributive property. Look inside that word and you'll see distribute. When we distribute, we basically share across an area, or maybe share is not the right word. We connect across. And so, in other words, A times the quantity B plus C means that A is distributed to B and it's also distributed to C. So this would mean A times B plus A times C. Now this one also works for subtraction because you can distribute the A to the B and you can also distribute the A to the C. All right, so let's take a look at some equivalent expressions here. So if we have 3 times the quantity 4x minus 1, you guys know that I would read that as 3 groups of 4x minus 1. we're going to distribute the 3 to the 4x. That's going to tell us how many x's we have. 3 groups of 4x gives us 12 x's. And then here I'm going to subtract 3 groups of 1. So I also have to distribute the 3 to the 1. 3 times 1 is 3, and I'm going to keep that subtraction sign. So I'm left with 3 times 4x minus 3 times 1, or 12x minus 3. We would say that these two are equivalent expressions. You'll be asked to determine whether certain expressions are equivalent. So let's look. Are 6 groups of n plus 3, or 6 times the quantity n plus 3, is that going to be equivalent to 6n plus 14? We can check by distributing out that 6. 6 times n and 6 times 3. Well, 6 groups of n is 6n, and 6 groups of 3 is 18. And that is not equal to 6n plus 14. Let's look at this one. Are 2 groups of x minus 3 plus 1 going to be equal to 2x plus 6? So distribute it out. 2 groups of x, 2 groups of 3 is 6. So we've minused 6 from 2x, and then plus 1. When we combine our minusing 6 plus 1, we end up with minusing 5, so we end up with 2x minus 5, and that is not equal to 2x plus 6. Okay, I also want to talk about simplifying, which essentially is what we have been doing a bit of, and so this will be a quick one. So you guys, I want you to know the term or the verbiage like terms. When we simplify something, we get it to a place where we can't combine anything else together that is alike. And so we're going to talk about like terms. Look at this example, x and an x and an x. We can combine those x's to be 3x because we have an x plus an x plus an x, so we have 3 x's. We would say the x's are like terms. Here's another example. We have 2 y's here, and here we only have 1 y. So 2y minus 1y is 1y, or just y. Let's go to an even more complex example. We have 4z minus 1z plus a z minus 2z's. Well, these are all like terms because they all have a z term. So we have 4z minus 1z is 3z plus 1z is 4z, it sounds funny, minus 2z is 2z. All right, let's look at where there are some without like terms. Take a look at this expression, a half n plus an n plus a half. These are like terms. Now, sometimes kids get confused because they think, well, there's a half and there's a half. Are those like terms? No, these are like terms because they both have n's. This is just a number. So we're not going to combine this just a number. We can't combine it with our n's, but we can combine our n's. So we have 1 n and a half of an n. So we have 1.5 n's plus a half. And this, you guys, is the most simplified version of that expression. This expression simplified gets us to that. We're going to simplify this one. Look at this, 2.5 groups of 20.5x plus 5.5x minus 10. So we're going to distribute out that 2.5. So 2.5 times 20.5 is 51.25x plus, now we're going to do 2.5 times 5.5x, and we have 13.75x. And lastly, we're subtracting now 2.5 groups of 10, which is 25. Notice that this has an x term, this has an x term, this does not. So here are our like terms, and we can combine those like terms. So if we combine 51 and 25 hundredths and 13 and 75 hundredths, we get 65. And those are x's. So we have 65x minus 25. And that is as simplified as it gets. All right. I hope that helps. Remember, you're doing 3.6 and 3.7 together, and then a superset. And I look forward to it. Thanks for listening, everybody.